Hi all. So we have reached to our second chapter, Computer Organization Introduction, Part 2. Basically, some points that we have already learned in the chapter number 1. Just we can brief it. Integrated circuits are basic building blocks of digital computers. As you know, ICs are very basic element whenever we are dealing with the digital computers. Logic gates are basic building blocks of logic circuit. So in the case of circuits, it's a main thing which is known as logic gates or logic circuits. We have some basic logic gates, some universal logic gates, and also some special purpose logic gates. That all we will cover in this chapter. Then computers use some storage space while processing the data. So if you are processing the data inside your system, it may be anything like any kind of media, any kind of coding, anything. Then we need some kind of storage space. But combinational circuit does not use any storage space that we have already covered in the previous chapter. It is just because it is taking only the present input and do not use the previous state as its input. So we have to keep track correctly the present input only. No need to take any previous state input. A logic circuit that is used for processing and storing bits is known as sequential circuit. I am repeating, a logic circuit that is used for processing and storing bits. It's known as sequential circuits. So we can discuss more about sequential circuit. Sequential circuit has memory element so that output can vary based on the previous state that is stored in the memory element. So, in the case of sequential circuit, we have to store the data or store the previous state outputs inside the memory. So, memory element can have a greater importance or greater role in the sequential circuit. These circuits uses previous input, output, clock and a memory element. Let us brief it. You can see the logical diagram or sequential logic here. Sequential circuit consists of feedback path and several memory elements. You can see in this diagram we are inputting something to the combinational logic. After getting the process, it is producing the output. And also, whenever we are producing the output, we are saving something in the memory unit. And after this process, if you need the memory element or the data whatever you have saved, then you can take it back to the combinational logic and we can again process the memory elements. So basically sequential circuit is equal to combinational logic plus memory elements. That means it is just similar to combination logic itself. But one and only difference is that in this sequential circuit, we are using memory elements or we need some memory space to store our data. But in the case of combinational logic, we don't need any extra memory to store anything because we are not storing anything. Then what are the examples of sequential circuit? Mainly we have the examples like flip-flops, registers, counters, etc. So the next topic is flip-flop. It is a sequential circuit which generally takes its inputs and changes its outputs at a particular instant of time. So we are taking the input for sequential circuit and also we are producing the output. but it will change its output at a particular instant of time. It is just because it is using some memory elements also, because it's a sequential circuit. Then used to store one bit of information. So in the case of flip-flop, we are storing one bit of information. Also considered as the most basic idea of a random access memory or RAM. It is also considered as a basic idea of RAM, random access memory. Then we can easily access this memory, and also we can store the data, we can retrieve the data, all things we can do. Then sensitive or triggered by clock pulses. What do you mean by clock pulses? Clock pulses means the time taking for any input. Whatever we are giving as input, then each and everything will be calculated with the help of clock pulses also. So it is sensitive and also triggered. Triggered means it is completely managed by the clock pulses also. That is, it changes its output only at the occurrences of clock pulses. So within the time limit only the processing will be taking place. A diagram will be there for clock pulses. Then the next example is for flip-flop. What are the type of flip-flops that we have? Mainly we have SR flip-flop, JK flip-flop and D flip-flop. But in this chapter we have to learn only SR flip-flop and D flip-flop. Then we can go to brief. SR flip-flop. Basically, SR flip-flops are also known with the other name, that is SR latch. SR latch. Mainly SR is a simple method or simple flip-flop, and also it is the basic flip-flop. Why we are using the word basic? It is just because we can make the other kind of flip-flops with the help of SR flip-flop. So this is the basic model. From this we are maintaining or we are making the new other flip-flops. So this is the basic one. Any flip-flop can be built using logic gates. So we are using logic gates to make the flip-flop. 1-bit storage element is in the SR flip-flop, like in the same way as we have already referred in the flip-flop, used to store 1 bit of information. Here also 1-bit storage element is here. Same points are here. Then one extra point is that bistable device that has 2 inputs. What do you mean by bistable? Bistable devices are the devices with the 2 stable states. 2 stable states. Then bistable devices that has 2 inputs. What are the input? You can see in the red box 2 datas are there. The code is like this: input S. So this is an input. Input S. It set the device. It set the device, or it is making the device ready for some process. It means the output of this circuit will be 1. So if we are giving the input S, it will be set the device to do something, and it will give you the output 1. This is generally labeled as S itself. So the first input is S, used to set the device. It will produce the output 1, and this input is generally labeled as S. Then what about the next input or second input? That is input R. Input R. It is used for resetting the device. It is used for resetting the device. As you can see in the card itself, it reset the device. It means the output of this circuit will be 0. Reset means it will go to the initial condition or initial state. If we are not doing anything, then in every program our condition will be staying in the value 0 because we didn't done anything. So our stable value will be 0 there. So like that, if we are resetting our device, it means the output of this circuit will be 0, and this input is generally labeled as R. So we have two inputs in SR flip-flop. That's why we are calling it bistable device. So what are the two stable states or two inputs? First one is S and the second one is R. So you can see the detailed diagram here. We are inputting two values. First is S. Then it stands for set the device. And the next input is R. It stands for resetting the device. Once the circuit is completed, then it will reset. It will reset to the initial condition. Then it will again continue its work. After getting two inputs, S and R, we will produce the output. What are the outputs available in this rectangle symbol? You can see Q is there and also Q complement or Q naught. Q naught means if you are getting the value 0 in Q, if you are getting the answer or output is 0 in Q, just the opposite of that value will be Q complement or Q naught. So what is the opposite of 0 in binary number? Obviously 1. So if Q is 0, then Q complement will be 1 or Q naught will be 1. Just opposite. Okay. Then we are getting two outputs. First output is Q and the Q complement you can see here. This is inverted output. Inverted output. Inverted means you are just complementing it. And also you can see that block diagram here. We have two input R and S. But not only the R and S, we can have another symbol here E. And also we can have another input in the rectangle symbol diagram, clock. So whatever we are giving as the input, it is completely depending upon the clock circle. So you can see in this diagram also, we are passing our input to AND diagram. Two AND diagrams are here, and also we are passing clock pulses to these AND diagrams, AND gates. After getting the output in the AND gate, it is going to NOR gate. NOR gate. How can we say that this is a NOR gate? Actually, after the OR symbol, you can see a bubble there. That bubble is indicating that this gate stands for NOR. NOR. So, my input R and E is passing to the first NOR and E and S is passing to the second OR. And after that, whatever you are getting as the output, that you can see in the Q. The first NOR will produce the output to Q and the second NOR will produce the output to Q dash or Q naught or Q complement, whatever you can use the word. And one more line is there which is indicating that whatever you are getting as the output in the line Q, that is passed to the NOR gate again, the second NOR gate. So the output Q will be passed to the second NOR gate. Then what about the Q complement? You can see the output to Q complement is passing to the first NOR in this diagram. To the first NOR in this diagram.